2 is 6. I was just wondering, can you guys see my mouse on the screen share?
Yes.
Yeah, okay. Great. So 3 times 2 is 6. So it divides evenly, right? 6 divided by 3 is 2. So here's our little 3 saying I'm a factor of 6. And what else is a factor of 6? Do you guys have any ideas? If 3 times 2 is 6? Okay, I'm going to call him Violet.
If 3 times 2 is 6, then 2 times 4 would be a factor of 8. So 3 times 2 also. Okay,
That's okay. That's right. 2 times 4 equals 8. Good. So now we're just actually looking at 3 times 2 equals 6. So if 3 is a factor of 6, what else in this equation is the factor of 6? Do you, Violet, do you have an answer, or should I? Yeah? Okay, does anyone want to answer? I'm going to call on Sarah.
Another factor, it doesn't equal to 6, but it's 5 times 2, and it equals to 10.
Good. So 5 times 2 is 10. So 5 and 2 are factors of 10. Good.
Yeah.
So okay, let's go back to this. So 2 was the answer I was looking for. So 2 is also a factor of 6 because 3 times 2 is 6. And so together, So together, when you multiply the factors together, you get 6. Good, let's keep going. So sometimes numbers have what we call common factors. So common factors is a factor that 2 numbers share. So let's look at an example. 3 is a factor of 6, and 3 is also a factor of 9. So that means that 3 is a common factor of 6 and 9. So they kind of share 3, right? Does everyone understand how 3 is a factor of 6? Because 3 times 2 is 6, but also 3 times 3 is 9. So 3 is also a factor of 9. So therefore, it's the common factor. It's being shared. Okay, so let's practice. Actually, I have a question for our moderator. So normally on Zoom, there's like an annotate feature, but I can't seem to find it on the webinar. Like where I can draw on my screen.
Are you on the whiteboard setting?
I'm on the screen share.
There is a whiteboard setting, I believe, in Zoom. Is that what you're talking about?
Or is this that's a pointer? Okay, hold on.
So you will have to go back, and when you screen share, it will give you a whiteboard option.
Okay, let me try that again. Sorry, you guys. This will just take a second. Would it be possible to draw on the screen that I'm sharing?
The current screen that you are sharing. Are you using Zoom or using another program?
I'm on Zoom webinar, yeah.
So you're on Zoom webinar. And how are you sharing your screen? Like, what screen are you sharing?
It's a Google Chrome screen.
I am not sure about that.
Okay, that's okay. Thank you. So I'm going to go to the whiteboard for a second. So let's practice finding factors. So let's go to 24. So the way we're going to do this is we're going to do this kind of chart, and then we're going to put 2 factors that multiply together to make 24. So for one example, we're going to do 1 and 24. Does anyone have Any other factors for 24? Okay, let me.
I do.
Go ahead.
4 times 6.
Good, really good. So we're going to write 4 here and 6 here. Awesome job. Okay. Does anyone else have any factors? Okay, I'm going to call on Siddharth. Hold on.
The grandma.
20.
Siddharth, I can't really hear you. Could you speak a little louder, please? Okay, so let's work through this together, Siddharth.
8 times 3 equals 24.
Times 3, good. So let's write that down.
Factors of 24.
Good job. So 3 and 8, we're going to put them here. Okay, awesome. Does anyone else have any? There's still a few more. I'm going to call on Callie. I don't know if that's working. I'm going to call on Shirley.
2 times 12 equals 24.
Awesome. Okay, so I think that's it. Yeah. So I think those are all the factors of 24. Awesome job. Hold on, let me just. Okay. Let's look at 18. Let's do the factors of 18. Okay, so again, let's start out. So we know that 1 times 18 is 18, so those are factors. So what are some other factors of 18? I'm going to call on Wayne.
9 and 9.
What did you say?
9 and 9.
Actually, 9 and 9, they're not factors because when you add them together, they're 18. So 9 plus 9 is 18.
3.
But what did you say?
9 and 2, 6 and 3.
9 and 2, 6 and 3. Good. So let's write that down. So does everyone understand that when we talk about factors, it's more about multiplication than addition, right? So 9 is a factor, but it's because 9 times 2 is 18. And then here, 6 times 3 is 18. Good. So those are all the factors for 24 and 18. So now let's talk about common factors. So are there any common factors between 24 and 18?
1, 2, and 3.
Good. Let me use a different color for this. Or I don't know if I can do that. Okay, I'm just going to circle. Okay, I got it. Good. So 1, 2, 3. What else?
4.
Are you sure? Because 4 is 4 a factor of 18? No, right? It doesn't show up in this factor list. 6. Someone said 6. Good. So these are our common factors. 1, 2, 3, and 6. So now, so just to give more people a chance to answer the question, even though some people are permitted to talk, please don't talk unless I ask you to unmute or call on you for that question. So yeah, what's the greatest common factor? I'm going to call on Gemma.
Can you hear me?
Yeah, I can hear you.
Okay. One of the factors is 6.
Yeah, 6 is the greatest common factor. Does that make sense? So greatest common factor, we sometimes call that the GCF. So the greatest common factor between these two, first we list out all the factors, we find the common factors, and then we find the biggest one they have in common. So in this case, it's 6. Cool. Okay, so let's go back to our PowerPoint. Hold on. Okay, so yeah, we use some different numbers, but that's the idea. So yeah, if we're looking at 24 and 16, you would do the same exact process. Okay, so let's practice finding some more factors. So let's do 28. I'm gonna go back to our whiteboard. Okay. Okay, I'm gonna call him Wilson. Okay, I think there's something went wrong. Let's call him Violet.
A factor is 2 times 14.
Good. 2 and 14. Awesome. Now let's call on Srita. Srita, I think you have to unmute yourself to speak. Okay, let's go to Caitlin then.
Hello?
Yeah, we can hear you. Do you have any factors for 28?
Some factors for 28 is 4 and 7.
Good.
Also, I have another question.
Yeah, go ahead.
When is this gonna get harder? Because I already know all of this.
Okay, so keep in mind that this is for grades 4 through 6. So what grade are you in?
I'm going to 4th grade next, but I'm in above grade, so technically I'm doing 5th grade math.
Okay, so does everyone feel that this is too slow?
I don't know.
You guys all raising your hand. Oh my god, I don't know. Okay. Okay, so okay. Can you guys put in the Q&A box as a question? Either too slow or too fast or just right. Does that make sense? Like enter in as a question, but answer my question. Does that make sense? And remember, only I can see your answers. So if I'm going too fast for you, like it's just be honest.
I don't think there's a Q&A box.
Okay, yeah, I'm not getting any response. Okay, thank you. Okay, so
Wait, real quick, you tutor, you can't see what they're typing in the chat?
No.
Oh, interesting.
I mean, not while I'm sharing the screen. Oh, I can
Should
go to
be able to pull up the chat box up at the top.
Okay, I just pulled it up. Too slow to eat. Okay. Okay, well, I'm getting a bunch of different answers. So you guys are just going to have to bear with me. We're going to go to some harder topics later, but I do want to make sure that everyone's able to keep up. So this is for a ton of people. There are like 1,000 of you on here. So just please be patient. But yeah, thank you for letting me know. So does someone else want to finish this up? Factors of 28. I'm going to call on Sid.
Hello?
Yeah?
The factors of 28. There's also a 7. Oh, you already did that. Okay. There's also
Think there's one. Okay, so there's a group of factors that applies.
1 times 28.
Good. 1 times 28.
I forgot that one.
Yeah, sometimes it's easy to forget that one, but remember 1 times the number is always itself. So those two are always going to be factors. Good. Let's really quickly do 49. Can someone raise their hand and give me all the factors of 49? Hold on, my mouse is frozen. I'm going to call in. I'm sorry if I mispronounce your names also. You can feel free to correct me. Yatin.
My name, can you hear me? Can you hear me? Excuse me, can you hear me? Hello?
Hey, I can hear you.
My name's Yatin.
Yatin. Sorry about that.
Yeah, the factors of 49 are 1 times 49.
Good.
Can I say more?
Yeah, go ahead.
And then there's 7 times 7.
Good.
And I think that's it.
Yeah, I think that's it as well. Good. So now, what's the greatest common factor of 24 and 49?
Can I answer that?
Yeah, go ahead.
It's 7.
Good. So 7 is the greatest common factor. Awesome. So I'm going to go back to my PowerPoint now.
You want me to mute myself?
Oh, yes, please.
Okay, you're welcome.
Okay. So I was using different numbers there. Okay, let's do 13. So what are the factors of 13? I'm going to call on Colin.
1 and 13.
Good. So are there any more, Colin?
No.
No, good. That was a trick question. Good job. So yeah, it is just 1 and 13. I'm not going to write it because I don't have that function right now, but yeah. So this our little helpful owl here is saying there's something special about the number of 13 and others like it. It's does anyone know?
Number.
Prime number. Good. It's a prime number. So what is a prime number? A prime number is a number that has no factors besides 1 and itself. So like 13, 1 times 13 is 13, and those are its only factors. So can you guys come up with some more examples?
3.
3, good. I'm going to call on someone else now. I'm going to call on Dylan. Hold on, let me.
Come, it's your favorite. Come, don't miss it. Run, run, run. Here.
Ooh.
Billy, go.
What did you say?
Billy, go.
2.
2, good. That's another good example. So yeah, there are a ton of prime numbers. Oops. Okay, I guess I didn't write it down, but yeah. So there's so many, like 2, 7, 19, 29. There are a ton of prime numbers, and they're special because, as you can see in this picture again, its only factors are itself and 1. So look at 4. 4 is not a prime number because it has 3 factors, 1, 2, and 4. So now let's do some factor trees. So a factor tree breaks down a number into its prime factors, and also it shows all the factors branching out like the roots of a tree. So, okay, so we were going to do 12. So now I'm going to go back to my whiteboard. Okay, so 12. So I'm not going to ask a question. I'm just going to do this one myself just to demonstrate. So let's start out with these factors 1 and 12. And then 1 is a prime number. You can't divide it by anything else, right? So we're going to circle that. So once you get a prime number, you circle it. So we're back to 12 here. 12, some other factors, we can do 2 and 6, right? And 2 is a prime number because its only factors are 1 and itself. So we're going to circle 2. And then 6, we have 2 and 3. So 2 and 3 are both prime numbers. So we're going to circle those, and that's the end of our tree. So you can think of it as like the tree roots are kind of like an upside down tree with the branches going down. Good. So now our prime factorization is, actually we're just going to ignore the 1 here, but our prime factorization is 2 times 2 times 3. So the prime factorization is breaking down a number into its prime factors and writing it out as a product of those prime factors. So this can also be written as 2 squared times 3. So it's an exponent, right? So 2 to the power of 2. So that's just another way to write it. Okay, cool. So let's go back to the PowerPoint. Okay. Awesome. So now it's your turn to make some factor trees. So let's do 15. Okay. Malik?
Yeah. Hello? Can you hear me?
Yeah.
My name is Malik.
Malik, sorry.
Yeah. So 1 and 15.
Good. So let's do that. And then 15, what can we divide that into?
15, 3 and 5.
Good. And now what?
And now you can do, wouldn't those both be prime numbers?
Good, yeah. So these are the prime numbers. So the prime factorization of 15 is 3 times 5.
5, yes.
Good, so that's it. So let's do one that's a little bit trickier now. Let's do 120. So who wants to tackle this one?
Can I go?
Can I go?
Is this Grayson?
120. What? So 40 and 30.
Good.
And the 30 and the 40 could be split into 10 times 3 and 10 times 4.
Good. Okay, can we split these up even more?
So 10, 2 times 5.
Okay, so we can do that for both 10s, right?
Yeah. And then the 5 into 2.5.
Okay, so that's good. 2.5 times 5 is 5, but right now we're dealing with whole numbers. So no decimals, no fractions. Remember the first slide we started with, the definition of whole numbers. So when we do these factor trees, we're only talking about whole numbers. So now that you know that, can 5 be broken up, or is it a prime number?
It's a prime number.
Good.
I just normally do things with decimals now.
Okay, well, for factor trees, we don't use decimals. But yeah, good. So now what else can we do? Grayson, do you want to finish this one?
So 2 can be split into 1.
1 and what?
1 times 1?
Well, 1 times 1 is 1, so 2 is actually a prime number because the only factors of 2 are 1 and 2. So we can circle 2. 2 is a prime number. 3 is a prime number as well. On this side, 2 and 5. But 4 we can break down more. So what can 4 turn into?
4 will turn into 2 and 2.
Good. 2 and 2. So now we have all the prime factors of 120. So we broke it up. And now the prime factorization of 120 is 2 to the power of 4.
Hey, what does that mean?
Okay, so
excuse me.
yeah.
You forgot to put the 0 at the end of 120.
What do you mean?
There's no
sorry.
0.
Thank you for correcting.
Sorry for interrupting.
No worries. Thank you. So 2 to the so let's go to talk about exponents for a minute.
Wait, excuse me. It should be 40 and 3, not 40 and 30.
Oh my gosh, you're totally right. I'm so sorry. Let me just erase this. Sorry. Okay. So right here, you're completely right. That was my bad. Thank you so much for correcting me there. So 40 and 3. Good. And then here, let's get rid of this. This is wrong. But if it was 1,200, that would have been exactly right, but it's 120. So thank you for correcting me. So the prime factorization of 120 would be 2 to the 3rd times 3.
I have a question.
Times 5. Yeah, we're going to go over the exponent in a minute. Okay, so 2 to the 3rd. So an exponent is when you have that little number on the top. So if I have 2 to the power of 2, that's what you call it, to the power of 2. So this basically means you're multiplying 2 by itself this number of times. So 2 to the power of 2 would be 2 times 2. Good, which is equal to 4.
Oh.
And then let's say we have 2 to the power of 3. That equals
6.
Not quite. That would be 2 times 3. So 2 to the power of 3 is 2 times 2 times 2. So you basically multiply the bottom number by itself 3 times because it's to the power of 3.
Oh,
so that would equal 8. 2 times 2 times 2 is 8. Let's try another one. What about 3 to the power of 3? Does anyone know what that would be?
I know.
I'm going to call on someone new, okay? But thanks for volunteering. Let's call on Isaac.
I'll make myself.
Okay, thank you. Is Isaac there? Okay, maybe something went wrong. Okay, let's call on Jaden. Let me see. Okay, oops. Okay, I just called on Amanda.
Really quickly, when they're done speaking, you can actually turn their speaking option off.
Oh, okay. Thank you.
Just in case you want to.
Okay. Do I is it like hovering over and then pressing mute after?
So you hover over the student, you click more, and the drop down will say disable talking.
Oh, okay. Thank you. Great. So Hannah, you're unmuted, right? So what is 3 to the power of 3? Can you expand that for me first? So write this in terms of regular multiplication.
3 times 3 times 3.
Good. And what does that equal?
That equals 9.
Are you sure? Let's start out with just 3 times 3. What's 3 times 3?
27, sorry.
Yeah, 27. Good. So 3 times 3 is 9 times 3. And then if we do 9 times 3, that equals 27. So 3 to the power of 3 equals 27. Awesome. So I'm going to go back to the chat. Does everyone understand exponents now? Can you write in the chat? Okay, awesome. Thanks. So let's continue. Let me go back to my PowerPoint. Okay. Okay, so now we're going to find the least common multiple of two numbers. So this one's a little bit tricky. So our example is going to be finding the least common multiple, which we abbreviate as LCM, of 30 and 45. So our first step is going to be to find the prime factorization of 30 and 45 separately. So let's do 30. Can someone raise their hand and tell me the whole prime factorization? Yeah. Okay. Hold on. My computer's really slow. There's a lot of people on here, so just give me a second. I just clicked on Dania.
Hello? Hello? Can you hear me? Hello?
Okay. Let's go to Edward. If no one has any. Okay.
Can you hear me? Hello?
Yes, I can hear you.
Okay. Wait, we're listing the factors of 30?
Let's do the factor tree because we're finding the prime factorization, right? So the way we get the prime factors is to do the whole factor tree. So, yeah. So can you give me the factor tree? Like you can list out like how we did it before. Yeah.
30 into 15 and 15.
Well, actually, it would be 15 and what? Not 15 and 15.
15 and 2.
Good. Why is it not 15 and 15?
Because then that would be a much bigger number.
Yeah. Hold on. I don't know why my computer is being. Okay. So 15 and 2. Good. So now can we break it down further?
15 could break into 3 and 5.
Good. Is that it?
Yes.
Okay, so let's circle all of these. These are our prime factors of 30. So when you multiply these all together, you get 30. Good. Now let's go to 45 because we're finding the least common multiple of the two. So, can Katarina? Oh, Katarina's no. Okay, Trina. Let's go to Kat. I think Kat is talking. Can you give me the factor tree for 45?
So, 15,
Good.
3,
Uh-huh.
And then divide 15.
5,
And what times 5 gives you 15? What's the other factor?
3,
Good. So can you tell me the prime factorization of 45?
5 and 3 and 3.
Good. 5 times 3 times 3. Good. So to find the least common multiple, so we know what a multiple is, right? Like a multiple of 3 is 9. Another multiple of 3 is 12. 3 times 3 is 9. 3 times 4 is 12. So it's when you multiply two numbers together, you get the multiple. So we're trying to find the least common multiple of 30 and 45. And we could just multiply 30 and 45 together, but then we would get a huge number. So we're trying to find the least common multiple. So the way you do that is you have to use your factor tree, use your prime factorization, and you use that as a tool, and I'll show you how. So basically, you're multiplying the prime factors together, but here, let me just do this out. So 3, so we look here at 30. We have 3 times 5 times 2. And then we look at this side, we look at 45. So 5, we already have 5 here. But this time we have 2 3s, and there was only 1 3 here. So we put another 3. So you multiply all the prime factors together, but they only show up in this. So this is our final big equation, right? Finding the least common multiple. They only show up in this big equation the greatest number of times they appear in each factor tree. So this might be a little bit complicated. Like, you might be wondering, why don't I have another 3 here? Because there's 1 3 here, 1 3 here, and another 3 here. But we only have 2 3s because the greatest number of times it shows up in one single factor tree is twice. It shows up twice here. So for 2, there's only 1 2 because there's only 1 2 here. And for 5, even though it shows up in both, in one single factor tree, the greatest number of times it shows up is 5. So if you multiply these together, 3 times 5 times 2 times 3, let's do that step by step. 3 times 5 is 15, then times 2 times 3. 15 times 2 is 30, times 3 is 90. So our least common multiple of 30 and 45 is 90. So you can see 30 is a factor of 90 because 30 times 3 is 90. 45 is also a factor of 90 because 45 times 2 is 90. So when we talk about multiples, it's kind of the opposite of a factor. Okay, so I feel like I kind of just said a lot of stuff. Can we go into the chat function really quickly and say if you understand this, or if you have any questions in the chat function, not raising hands? Let me scroll down. Okay, so most people understand, so I'm going to move on, but you can always Google how to find the least common multiple and find a bunch of videos and stuff to help you. So yeah, this can be a little bit tricky at first, but I think most of us have got it, so we're going to move on. Okay, so I'm going to go back to my PowerPoint. Sorry about this, like, moving around, but okay. So here's just kind of like a recap of what we did. This is the prime factorization for 30. Here's the prime factorization for 45. And you multiply the prime factors the greatest number of times they occur in either factor tree. So no, this is not correct because we have too many numbers there. This is correct. Yep, 90. Awesome. So now you try. Let's find the least common multiple of 12 and 8. Okay. Let's see. Hold on 1 second. Okay, 12 and 8. Okay, a lot of people have already said 24, which is really good. So let me just write that out really quickly. So 12, our factors are 3, 4. 3 is a prime number. We'll circle that. 4 can be divided up into 2 and 2. And 8 can be broken up into 2 and 4. And then that becomes 2 and 2. So our prime factorization is going to be our least common multiple is going to be 3 times 2 times 2 times 2. So 3 times 2 to the power of 3, because you're multiplying 3 of them together, which is 3 times 8, which is 24. Good. Okay, can you please load? Okay, so some people don't understand this. That's okay. So I'm going to go through this again. So the question was, find the least common multiple of 12 and 8. So the first step when finding the least common multiple, okay, one person asked why I put a dot instead of an X for multiplication. So once you get into algebra and other things, we're gonna go a few days in advance, but once you get to algebra and stuff, the X is a variable. So it can get a little bit mixed up. So we use the little dot in the middle to represent multiplication. Good question. So going back to the people who didn't understand this, find the least common multiple of 12 and 8. So remember, the first step when we're talking about finding the LCM is to make the factor trees. So here we've made the factor trees of 12. So does everyone understand how we got the factor trees? Okay, good. So the factor trees, we got that. The prime factorization of 12 is 3 times 2 times 2. So, good. And then for 8, we did the factor tree, and the prime factorization is 2 times 2 times 2. So now, this is the tricky part. So the least common multiple, we're going to multiply these prime factors together, but they only show up in, when I say big equation, I mean, this is hold on. This is like the big equation that I'm talking about. They only show up in this big expression the greatest number of times they appear in each factor tree. So let's just look at the factor 3. So 3 only shows up in 12's factor tree one time. So there's only 1 3 here. Now let's look at the number 2. So in 12's factor tree, 2 shows up twice. In 8's factor tree, 2 shows up 3 times. So we're going to take the 3 2's because the greatest number of times it shows up is 3. So yeah, so the least common factor is 3 times 2 to the power of 3, which can be written as, let's just make a little note here, 2 to the power of 3, which is the little number on top, 3 is the exponent, is 2 times 2 times 2. And so just reiterating, 2 times 2 times 2. We have 3 2's here because there are 1, 2, 3 2's here. Here there's 2 2's, but that's not the most number of times they show up. So we're going to go off of this, 3 2's. Okay. Why is there no 1 or 8 or 12 in the tree? That's a good question. So for the first tree that I demonstrated, we actually did like every factor. So if we did 12, we would do 1 and 12 first. But actually that's not really necessary because 1 times anything will be itself. So it's not really necessary to have that 1 in there again. So we can just speed it up by doing, you just go directly to the 3 and the 4 or the 2 and the 6 or whatever you want to do. So you can just speed it up. 1 isn't a prime. Okay, so Jaden said 1 isn't a prime. So 1's like a weird number. There's debate over if it's a prime number or not. So yeah, we're just going to leave that out of the factor tree. Could we have written out 2 times 2 times 2? Yes, you can. So 2 times 2 times 2 is the same thing as 2 to the power of 3. So if we go over this again, the little number, which is called, this is called the exponent, the little number on top, is the number of times you're multiplying the number by itself. So these two expressions are equal. Okay, so people are still asking what to the power means. So this, okay, let's clear this for a second. So 2 and this little 3 on top. So the way you say this would be 2 to the power of 3. If what we had was 3 and a little 5 on top, this would be 3 to the power of 5. You can't hear anything? Can everyone hear? Someone said they can't hear anything. Yeah? Okay, good. So yeah, so the reason why we have that weird little number on top is it just makes it easier, because if you wanted to write out 3 times 3 times 3 times 3 times 3, it would take up a lot of time. So 3 to the power of 5. And also one other thing is sometimes you'll hear 3 squared. So 3 squared is just 3 to the power of 2. 3 times 3. So when something is raised to the power of 2, you can call it squared. That's when you square something, which is 9. So 3 squared equals 9. Awesome. So I was going to, so the next topics that I was going to go over are fractions, but I think that we can just end here for now and do some questions about what we've learned today, and we can start fractions next time. So if you have any questions, you can type them in the chat box. I think that's easier. Is there any symbol so that you don't have to say the word power? Yeah, so that's exactly what I was talking about, the exponent thing. Oh, just one note, I see a bunch of people still raising their hands. My computer is like a little bit slow, and it's easier if you just write in the chat so I can see your questions. Thank you, guys.
Lagging too.
Okay, yeah, it's a lot of people, so it's lagging for a lot of us. Okay, so what was the question? Okay, a symbol for to the power of. So this is it. 2 to the power of 3. So notice how our exponent, 3 is called the exponent, is really little and to the upper right. So that's a way to write it. If you're writing on a computer, sometimes people will write it with a little caret, 2 to the power of 3. And that means this 3 is a little tiny 3 on top. Awesome. What does square root mean? Good question. So square root relates to exponents, right? So remember I said 2 squared, 2 to the power of 2, equals 2 times 2, right? Which equals 4. So the square root of something is the opposite as raising something to the power of 2. So the symbol for square root is this thing. Have you guys seen this thing before? This is the square root of 4. So we're basically asking what times what equals 4. Right? But we need these two things to be the same number. So the square root of 4 equals 2, because 2 times 2 equals 4. And you can also write this as 2 squared, which is with the exponent, equals 4. Someone asked if could 3 to the power of 5 be called 3 to the 5th power? Yes, I think so. I think that's the same. Someone asked, why can't there be a decimal in a factor tree? Good question. So in a factor tree, if you had decimals, the possibilities would be endless. Because if you're including decimals, there are just infinite numbers of possibilities with decimals. Anything can be divided by anything. It'll just never end. So when we talk about factor trees and prime factorizations, we're only dealing with whole numbers. Okay. For everyone saying that you've learned a lot and you like this class, I'm really glad that you like it. I've had a lot of fun preparing for it. So yeah, I'm glad that you like it. Let's see. Is square root only for even numbers? No, that's a good question. So let's look at the number 49. So can you guys write in the chat what you think the square root of 49 is? 7, good. Really good job. So 7, that's because 7 times 7 equals 49. And 7 times 7 can also be written as 7 to the power of 2, which is also called 7 squared. Remember, anything to the power of 2 is, when you say it, it's that squared. It means the same thing. Good. And 49, is 49 an even or an odd number?
What?
Odd. Good. Yeah, so 49 is an
Why is
odd
this
number.
thing laggy?
It's lagging. Yeah, I'm sorry. There are a lot of people on this, which is awesome, but it can lag sometimes. So just try to be patient.
It's just your
Awesome.
voice sounds
So-
like it's crackling.
Oh, I'm sorry. We have a few more minutes left, so I'll try to fix it for tomorrow. Let's.
It's
Okay.
actually fine. I can hear perfectly.
Oh, okay. Thanks. Thanks.
I
for
was
your
gonna say
feedback.
you're fine. It's something either to do with Zoom or the student center.
Okay. Yeah, awesome. So going back to that question, no, a prime number does not have to be even. There are plenty of odd prime numbers. I mean, a squared number doesn't have to be even. Is there a sign for squared? Someone's asking. Okay. So there's no sign for squared besides putting the thing to the power of 2. That means 4 squared. There's no separate sign. Sorry, it's hard to write. 4 squared. And someone's asking about cubed. So that's the same thing as squared, kind of, but we can, 4 cubed would be 4 to the power of 3. And that would be, you would say that as 4 cubed or 4. Does that make sense? So that's what cubed means. Someone asked, why is 2 the square root of 7? It's actually not the square root of 7. 7 is a prime number, and there's no square root of 7 unless you get into really long decimals. And, like, for example, pi is like one of those never-ending decimals. So we're not talking about those yet, but 2 is not the square root of 7. 2 is the square root of 4, because 2 times 2 is 4. Okay, someone is asking, what is the difference between LCF and LCM? So I feel like LCF is not really used super often. So here are the ones that we're using. We're using GCF, which is greatest common factor. And we're also using LCM, which is least common multiple. So I'm assuming LCF would be the least common factor. And LCM is the least common multiple. So let's just go back to talking about what factors and multiples are really quickly. So if we say like 3 times 2 is 6, these are the factors. Oops. 3 and 2 are the factors. And since they multiply together to get 6, 6 is the multiple. Okay. Let's see if we have. Yeah, and someone said GCM, greatest common multiple. Good. Someone is asking, what is the symbol for square root? Good question. So let's say we have 16. So this is just regular 16. If I want to say the square root of 16 is like this. So this weird thingy, that's kind of what the house over the 16 means, square root of, and the number in the middle. Okay. Awesome. So we're going to end in a couple minutes. For people asking if I'm seeing your messages, I do see them. There are just so many messages. I'm sorry I can't answer all of the questions or respond to all of them. They're all really good questions. But yeah, thank you so much for, let me stop this share. Thank you so much for coming to this class. I had a lot of fun, and I hope you learned a lot. We're going to be meeting tomorrow at the same time, and we're going to be starting fractions. So yeah, I hope you all have a good day, and I'll see you tomorrow. Bye, guys. Thank you. Oh, for people asking if I can send the PowerPoint, I'm not completely done making it for the whole week, but maybe at the end of the week I can reach out to Varsity Tutors and maybe email it to you guys. Awesome. Okay. Bye, guys. See you tomorrow.